Now, coming to the first question, in exercise 4, a drinking glass is in the shape of frustum of cone of height 14 centimeters. The diameter of two circular ends are 4 centimeters and 2 centimeters. Find the capacity of the glass. Now coming to the solution. Here, he has given a drinking glass in the shape of frustum. Here the height of the frustum is given as 14 centimeters. Therefore, let us note down it as height h is equal to 14 centimeters, and he has given the diameter of two circular ends. Let it be as the smaller one 4 centimeters and the larger one, let it be as smaller one 2 centimeters and the larger one 4 centimeters. Therefore, here the radii of two circular ends, let us represent it as R1, that is equal to larger one, which is half of diameter, that is 4 by 2, which is equal to 2 centimeters, and the radius of smaller end is equal to diameter by 2, that is 2 by 2, which is equal to 1 centimeter. Now he is asking the capacity of glass. We know that the capacity of glass is equal to volume of frustum, that is 1 by 3 pi h into R1 square plus R2 square plus R1 R2, which is equal to 1/3 times pi value, let it be as it is now, into height is 14 centimeters and R1 square is 2 square plus R2 square is 1 square plus R1 R2 is 2 into 1, which is equal to 1 by 3 into pi value is 22 by 7 into 14 times 2 square is 4 plus 1 is 5, 5 plus 2 is 7. Here 7 goes in 7 one time, and 22 times 14 is 308 divided by 3 centimeter cube. Therefore, the capacity of the glass is 308 by 3 centimeter cube. Now coming to the second question, the slant height of a frustum of cone is 4 centimeters and the perimeters, that is circumference of the circular ends, are 18 centimeters and 6 centimeters. Find the curved surface area of the frustum. Now coming to the solution. Here he has given the slant height of the frustum. Let it be as L is equal to some 4 centimeters given, and he has given the circumference of two ends. Those are 18 centimeters and 6 centimeters, and asked us to find the curved surface area. We know that curved surface area of frustum is equal to pi into sum of radii of two circular ends into slant height L. But we need the values of capital R and small r. But he has not given the values directly, but he has given the perimeters. So here the perimeter of circular ends are given by 18 centimeters and 6 centimeters. As here the radius of the larger one is 18 centimeters, we can equate 2 pi into capital R is equal to 18, and the smaller one is smaller, so here 2 pi into small r is equal to 6 centimeters. From here we get small r is equal to 18 by 2 pi, that is 9 by pi, and from here we get small r is equal to 6 by 2 pi, that is 3 by pi. Now the curved surface area of the frustum, let this be as C, that is C will be equal to pi into capital R plus small r into L, which is equal to 22 by 7 into small r plus capital R is 9 by pi plus 3 by pi into L is 4, that is equal to, here we have pi as it is. If we take pi LCM in this, we get pi, and 9 plus 3 is 12 into 4. Pi and pi will be cancelled, and 12 times 4 is 48. Therefore, the curved surface area is 48 centimeters square. Now coming to the third question. FS, the cap used by the Turks, is shaped like the frustum of a cone. See figure 13.24. If its radius on the open side is 10 centimeters, radius at the upper base is 4 centimeters, and its slant height is 15 centimeters, find the area of material used for making it. Now coming to the solution. Here he has given the cap in the form of frustum. Here the radius of open end of the cap is given as R1, that is 10 centimeters, and the radius of top position of cap, that is R2, is given by 4 centimeters. The slant height of the cap L is equal to 15 centimeters given. He is asking us to find the area of material used for making it. So here if we observe the cap, the area of material used will be for making the curved surface area of this cap and also the top surface. So the area of material used will be equal to the surface area of the frustum is pi into R1 plus R2 into slant height, plus the top surface area of circular section is pi into R2 square, that is equal to pi value is 22/7 and R1 plus R2 is 10 plus 4, that is 14, and slant height L is given by 15 plus pi value is 22/7 into R2 square is 4 square, which is equal to, here 7 goes in 14 2 times, and 22 times 2 is 44, and 44 times 15 is 660, plus 4 square is 16, and 16 times 22 is 352 divided by 7, that is equal to, let us take here 7 as LCM, then we get 7 times 660, that is 4620 plus 352 by 7, which is equal to 4972 by 7. Let us convert this into a mixed fraction. Then we get 49 goes in 7 times and 7 goes in 7 one time, and we'll be left with 0 here. 2 by 7 centimeter square. Therefore the area required for making the cap is 710 2 by 7 centimeter square. Now coming to the fourth question. A container opened from top and made up of metal sheet is in the form of frustum of cone of height 16 cm with the radii of its lower and upper ends as 8 cm and 20 cm respectively. Find the cost of milk which can completely fill the container at the rate of Rs 20 per liter. Also cost of the metal sheet required to make the container if it costs Rs 8 per 100 cm square. Take pi is equal to 3.14. Now coming to the solution. Here he has given a vessel in the form of frustum in which the milk is poured. The dimensions of the frustum are the lower radius as here the radius of the largest circular portion is 20 centimeters and radius of smallest circular portion is 8 centimeters, and the height of the frustum h is given as 16 centimeters. Now he is asking us what is the cost of milk that can fill the complete container. So here the radius of larger circular portion is 20 centimeters and the smaller circular portion is 8 centimeters. Here the height of the frustum, that is vessel, is given as 16 centimeters. So as he asked us to find the cost of milk that can fill the container completely, let us initially find the what is volume of the container. As it is in the form of frustum, we have the volume of frustum as 1/3 of pi h into r1 square plus r2 square plus r1 r2, that is equal to 1/3 of pi into h value is 16 centimeters into r1 square is 20 square plus r2 square is 8 square plus r1 r2 is 20 into 8, which is equal to pi by 3 times 16 into 20 square is 400 plus 8 square is 64 plus 20 into 8 is 160, which is equal to pi by 3 into 16 into 400 plus 64 is 464 plus 160 is 624. Here 3 goes in 624, 208 times, and 208 times 16 is 208 times 16 times pi value is 3.14 to be considered, and this value is equal to 10,449.92 centimeter cube. We know that 1000 centimeter cube is equal to 1 liter. Here let us convert this value into liters. Then we get the value as 10.44992 liters. He says that 1 liter of milk costs rupees 20. Therefore, cost of milk that can fill whole container is equal to rupees 20 into 10.44992, which is approximately equal to rupees 209. That is the cost of milk for filling the container. He is also asking us to find the total surface. He is also asking us to find the amount of the material required to make the container, that is area of container is equal to area of material required to make it, that is here curved surface area, which is pi into r1 plus r2 into L, plus as it is a vessel it will be having the down surface area, that is pi into r2 square, but we don't know the value of L. For the frustum, the slant height is given by L is equal to r1 minus r2 whole square plus h square, which is r1 minus r2 is 20 minus 8 whole square plus h square is 16 square, which is equal to square root of 12 square plus 16 square, that is square root of 144 plus 256, which is equal to square root of 400, that is 20 centimeters. So let this be as sum A. Now we have all the values. So now area of the material required will be equal to pi, let us take common, then it will be r1 plus r2 20 plus 8 into L is 20 plus pi into r2 square is, here we need only r2 square, that is 8 square, which is equal to pi into 20 plus 8 is 28 into 20 is into 20 is 560 plus 8 square is 64, which is equal to pi times 624, but we have the value of pi as 3.14. Therefore 3.14 into 624 is equal to 1959.36 centimeter square. He has given that 100 centimeter square of material costs rupees 8. Then what about the cost for 1959.36 centimeters square? Let it be as some x, so we need to find this. Now by applying the ratios concept, we get 100 by 1959.36 is equal to 8 by x, which implies x is equal to 8 into 1959.36 divided by 100, whose value is approximately equal to 156.75 rupees. Therefore, the cost for making the vessel or container is equal to 156.75 rupees. Now coming to the fifth question, a metallic right circular cone 20 cm high and whose vertical angle is 60 degrees is cut into two parts at the middle of its height by a plane parallel to its base. If the frustum so obtained to be drawn into a wire of diameter 1 by 16 centimeters, find the length of the wire. Now coming to the solution, in this let us consider the height of the right circular cone from which the frustum is made is 20 centimeters. So this total height represented by the imaginary line will be 20 centimeters and the vertical angle is given by 60 degrees. So this height and this perpendicular will bisect this angle here. So each angle will be 30 degrees. Now he says that this cone is cut in the exact center by a plane parallel to the base of the cone. So the frustum is formed. So this height will be equal to 10 centimeters and this height will be also equal to 10 centimeters. Now he says that from this frustum wire is drawn, each of diameter 1 by 16 centimeter, and he is asking the length of wire formed. So as the complete frustum is converted into the wire, the complete volume used to make the frustum is utilized for making the wire. So we need to initially find the volume of frustum and then equate it to the volume of wire formed. Now for the frustum, we have volume is equal to 1/3 of pi h into r1 square plus r2 square plus r1 r2. But we need here the values of r1 and r2. Let this be as r1 and let this be as r2. Here to this the height is h1, that is 10 centimeters, and here to here also it is 10 centimeters. Now let us represent these parts by some a, b, c, d. Now in triangle ADC is 90 degrees and here we have the angle as 30 degrees. In this triangle, by applying the trigonometric ratio tan 30, which is equal to opposite side by adjacent side, in this triangle the tan 30 will be equal to R2 by complete height, that is 10 plus 10, 20. Now we get the value of R2 as 20 into tan 30, that is 20 by root 3. Again, if we consider this shorter one, here the vertex is A and here consider some P and Q. In triangle APQ, we again apply tan 30 is equal to opposite side is here PQ by height is AP, that is 10, which implies PQ is equal to 10 into tan 30, that is 10 by root 3 centimeters. Here PQ is radius of the smaller cone. So here we got the R1 and R2 for the, and here, and let this be as R1. So here we got the R1 and R2 for the frustum. So it is easy to find the volume. Therefore volume is equal to 1/3 of pi, let it be as it is, and h is here distance between two circular portions, that is 10 centimeter, and r1 square is 20 by root 3 whole square, that is 400 by 3, plus here the r2 square is 20 by root 3 whole square, that is 400 by 3, plus r1 square is 10 by root 3 whole square, that is 100 by 3, plus r1 r2 is 20 by root 3 into 10 by root 3, that is 200 by 3. Now we get 1/3 of pi into 10 into 400 plus 100 plus 200 is 700 by 3, which is equal to, if we multiply this, then we get 7000 pi by 9 centimeter cube. This is the volume of frustum. Now he says that this frustum is drawn into wire of diameter 1 by 16 centimeter. So the diameter of wire is given as 1 by 16 centimeter. Therefore radius will be equal to half of this, that is 1 by 32 centimeter. Now let us assume that length of wire is L. As the cross section of wire is cylindrical, we can say the volume of wire is pi r square into L, that is pi into 1 by 32 whole square into L. But this volume of wire will be equal to the volume of the frustum, that is 7000 pi by 9, which implies pi on both sides of equality will be cancelled. Now L is equal to 7000 into 32 into 32 by 9. That value is equal to 7,96,444.4 centimeters, which is equal to 7,964.44 meters approximately. Therefore, the length of wire that is formed by frustum is 7,964.44 meters.